Let's discuss assigning R and S configuration. We have to remember the Cahn-Ingold-Prelog rules basically state that the substituent with the higher atomic number gets priority. So if we look at this first molecule, we have four substituents. We have an ethyl group right here, methyl, chlorine, hydrogen. And the chlorine has the highest atomic number. That gets first priority. Hydrogen will always get number 4 priority. And then we have to decide between the ethyl group and the methyl group. They're both a carbon right here. So then we look at what these carbons are attached to. And it typically helps to make a list. So the carbon attached to the on the right side is attached to 3 hydrogens. I like to make a list like that. Then I compare it to the list on the other side. So this carbon is attached to another carbon further on the chain, and then 2 hydrogens. And what we're looking for here is the first point of difference. So the first point of difference is this carbon. There's a hydrogen there, that should be an H. The carbon wins over the hydrogen. So really what we're going to quickly come to memorize is that ethyl always beats methyl. So methyl is always the lowest priority of any carbon group. So we have a 3 for that one and a 2 for the ethyl group. And so now the rules state that the group 4 needs to be arranged towards the back, and of course we see here that it is arranged towards the viewer. It's in front of the plane of the paper. And so we could either redraw this molecule, or we could just go ahead and assign priority as though the H were in the back, and then at the very end change our priority. So let's count 1, 2, 3, and we come up with a counterclockwise direction. And that's normally S, right? But remember that our hydrogen is in the wrong position. It's in the absolute, or the totally opposite position. And so we need to change that to R. And so here, this is an R stereocenter. We assign priority. We observe that 1, 2, 3 goes in a counterclockwise direction. And then we reversed our choice of S into R because the hydrogen was in the wrong spot. Alternatively, we could have redrawn the molecule, and it would look something like this. In order to put the hydrogen in the back, all we have to do is flip the Cl and the hydrogen. And I remember also that if we flip 2 groups, we've inverted the stereochemistry. So we want to flip the other 2 groups as well. So if I make that into an ethyl, try that again. Now I flipped 2 groups, and then I flipped 2 more groups. So these molecules are identical. I could assign stereochemistry to either of them and come up with R. So let's try that here. The chlorine is 4, hydrogen's 1, the ethyl is 2, methyl is 3. If I count, the hydrogen's 4, chlorine's 1. If I count 1, 2, 3, I come up with a clockwise direction, and that gives me R. So we can use a couple different techniques here to establish the absolute configuration. So let's look at the second molecule now. And of course we have a hydrogen, we've got an ethyl group, we've got a methyl group, and an OH group. And we've already discussed how to assign priority. We know that the O has the highest atomic number out of all the carbons and hydrogens. And we know that ethyl always beats methyl. So now we can observe that the hydrogen, it is not on the wedge, nor is it on the dash. It's actually in the plane of the our paper. And so that's going to create a little bit of a conundrum for us. There are a couple ways we could handle this. We could envision ourselves looking down this arrow as though this were a Newman projection, looking down the CH bond. That would put the hydrogen behind us, and then we would get 1, 2, 3 counting in a counterclockwise direction. And so that tells us that that's S. If you can't envision that, it would look something like this. and then the H is right behind the C. I'm not even going to draw it. And so we would be counting like this. Counterclockwise is S. Alternatively, we could swap two groups. Let's swap the H and the methyl, because we know that we want the H in the back. So here's the methyl. We swap the H and the methyl. And now we could assign priority to everything here, leaving the OH and the ethyl in the same place. And again, 1, 2, 3, 4. Here we get clockwise, which is R. However, since we swapped the H and the methyl as we went to this new blue drawing, we know that we ended up drawing the enantiomer. So we should take our R designation from this new blue drawing and turn into S, because we know that this is the enantiomer of the original drawing. So there's a couple different ways you can handle this as well. And if we have something more complicated than hydrogen or ethyl in the plane, you can always sort of just put an X there. Or even, there's no reason we couldn't draw something like this, where it's just the priorities. And if that helps you visualize things in a more cleaner interface, then I encourage you to do that. So drawing this with the priorities simply representing the large groups can sometimes give us a cleaner drawing.